Hi guys, greetings from Bulgaria. In today's video we're going to discuss the data-driven testing pattern, part of our video course about design patterns in automated testing. So, until now we have already covered 7 design patterns. In the first module out of our course we discussed the adapter design pattern for improving some of the interfaces like iWebDriver, iWebElement. We added some new functionality and made our test much more maintainable and readable. Next, in the second module, we discussed the decorator design pattern, helping us to bring extensibility to our mini-test framework. After that, we covered the singleton design pattern that it's very popular when you want to improve the API usability of your test library. It works together with other design patterns such as page object model, factory, builders, repositories and others. Next we cover dependency injection, that it's very useful in a little bit more complex scenarios like test automation frameworks. After that we discussed troubleshooting features, working with the chain of responsibility design pattern, and we covered strategy that can help us to add new functionality such as new ways for how we can find elements or new weight strategies. And in the last module we covered the repository and factory design patterns that are essential for the test data management. The HTTP repository basically wraps the database or works as a client for our API for CRUD operations and adding new data to facilitate our automated tests. And as I said, in this module we're going to cover the data-driven testing pattern. In a minute we're going to start, but before that hit the subscribe button if you haven't already, so that you get notified when new videos are published each week on the Awesome Lambda Test YouTube channel. Also check the Lambda Test blog, where there are many awesome articles covering the best practices in the industry about automated testing. Also, in the links below you will find the full source code. I suggest to play along, clone it and check it out. You will find also jump links if you don't want to hear the beginning of the video or some of the explanations. You can directly jump to the section that you're interested in, and also you can increase or decrease the speed of the video. And you will find many useful resources there, like articles and other related videos. So let's get started. First, we're going to discuss why you need to care about a data-driven pattern. We're going to use the Lambda Test Playground as always. Here is very applicable. We are going to see in action automated tests for the shopping cart. Then we're going to discuss in more detail the data-driven pattern, especially using test frameworks such as NUnit, but this is applicable for other unit testing frameworks like MSTest, XUnit, or if you use Java for testing JNJ-Unit. After that we're going to see the refactor tests, but using the data-driven pattern in tests. So let's get started. First I want to show you the scenario that we're going to automate. As I said, as always, we use the Lambda Test Playground. I'm not going to write any code, but again, directly you can clone the repo. So in this particular instance, we're going to focus more. You will have specific test cases for the products, for the search, for the results. Here we're not interested in that, but instead we're going to jump directly to the checkout page. Here again, for this specific page, we can utilize the same pattern and the same practices that we are going to discuss, but there are many more test cases that we need to write here, like increasing the quantity, update, delete, using coupons, volume discounts, many others. But again, we'll just directly jump to the checkout. So for the checkout, we will focus on one of the happy paths where we are registering a new account. But this is not the main focus. The main focus is that for every operation here, the most important part here is to verify the data and especially the prices, what you're going to bill the client. Again, there are many variations and hundreds of test cases here just for the prices. However, we need to focus more on this taxes feature. This is your new requirement for checking the sales tax, the VAT tax, and especially in this episode we are going to discuss more the VAT tax. For those of you who are not familiar with what VAT stands for, this is value added tax, which is widely used in Europe. Each Europe country has a different VAT tax. Here is this website. So as you can see on the map of Europe, each country, for example, France has a VAT tax of 20, Romania has a 19%, Poland has 23, etc. So we need to verify those taxes. This means that if you increase the quantity here or update delete items, these taxes need to be pre-calculated. They need to be calculated again. And this tax is applied on the subtotal, and after we actually maybe there is a bug here. Usually if you have discounts like coupons, etc., they need to be after the taxes. So this means that when you change the country, you know, the VAT tax will be pre-calculated. We are going to create a UI test for that. Again, a note here. It depends how your system works behind the scenes. If you have an endpoint web API that is responsible for making all of those calculations, maybe the best place to put most of the tests is actually on an API level, web API, right? Or writing unit tests. Sometimes this is not possible since many popular front-end shopping carts, they're actually using third-party providers such as PayPal, CyberSource, and others. Basically they are directly in the front end using the JavaScripts, using asynchronous JavaScript to make all of the calculations. This means that the only way you can verify all of the bindings, all of the refreshes of the prices is to check them here, and on top of that probably you will need web API tests again. So here in the solution, again, this is a simple NUnit project containing WebDriver tests. In this project, if you're not familiar with NUnit, I suggest to check the Lambda test videos about NUnit. There is a whole series, but in short, NUnit is a very popular unit testing framework. We're going to cover some of its features later on when we discuss the data-driven testing pattern. And in order to use it, you can use the predefined projects. When you click new project, there is a version of NUnit, or you can directly install the NUnit dependencies here. You need this for NuGet packages. And on top of that, I installed all of the related Selenium projects, dependencies. In the .NET world, we use NuGet. In Java, you probably use Gradle or Maven. And I installed some for backward compatibility like WebDriver Manager, but if you use 4.11 and above, you just install the latest Selenium and it will download the driver itself. So before we look into the, again, I won't couple this particular video with the other patterns that we use because I want to keep the things simple. However, in NUnit, we put our tests in a test class annotated with this attribute test fixture. And in the setup phase, this is the method that will be executed before each test. We initialize the driver. Again, for backward compatibility, we use the WebDriver Manager, which will detect which version of the browser you have, for example Chrome, and it will download the proper driver. The driver is responsible, you know, your code is communicating with the driver communicates with the browser. Again, if you use 4.11 of Selenium, now the newest versions, they use the so-called Selenium Manager, which is doing that automatically for you. So here, later on in the video, if you don't want to execute your tests on your local machine, but in the cloud, here this will be the place where we are going to put all of the Lambda test capabilities, for example. Again, there will be demo about that. After each test, we close the session in the browser. And as you can see here, I have variations as a comment of all of the important test cases that I need to automate here for checking all of those VAT percentages and the calculations. For each country, I'm selecting one of the test cases to select one product, and then to have one more test that basically added 9 of those items. Of course, there are many other cases, like as I said, updating, removing, adding 2 products, coupling this with discounts. Again, let's keep it simple. But again, the first thing here is the quantity, then the country, then the expected VAT percentage, which is 2021 or more. The expected VAT tax, this is the actual tax. As you can see, for one product is 33, and then just multiply it by 9, and you will find the expected VAT tax for 9 items. And this is the total. Again, the total can be different depending on other discounts and taxes as well. Again, we are keeping it simple, just discussing the VAT tax, because there are other taxes as well for other continents and countries outside of Europe, like sales tax for India or United States or Canada, but their calculations are much more complicated. So, as you can guess from the name, here my name is Check the VAT displayed when we pick Croatia for the billing, and the quantity is 9. So the first thing that I change here is the quantity of 9. If I need to explain really quickly my structure here, we use the page object design pattern, very popular design pattern in automated testing. We basically discuss it in each of the modules. But in short, what is it? We have a class that holds all of the elements with their locators, all of the actions that we are going to do on the page. Many often we use model classes, as we will refresh in a minute. Instead of providing 6 or 7 parameters, we provide a single class holding all of the input parameters. And sometimes in some implementations we can put the assertions as well, especially if they are more complex or require additional operations there. And so here are our pages. We have one base class here holding references to the WebDriver, weight, and the actions. And all of those pages here, they basically derive from this base page called the base constructor. As I said, we are waiting for most of the elements here to be visible, to exist. And we have all the actions. The interesting part lies here in the checkout page, where we have most of the elements. Again, for now, let's not focus on the actual, there are many other videos regarding how to write locators and such. But yeah, we have all of the elements first, then we have all of the actions. As I said, we prefer to have bigger methods that are grouping the actions, which defines the so-called DSL or domain-specific language, making our test much more readable, because you see the range phase, the data, and then just the actions, and we are hiding all of the details here. So we have few user input, few billing address, and we have some assertions. The 3 important assertions are assert total, assert VAT percentage, and the VAT tax. Sometimes you can put here some exception messages to make the troubleshooting easier. You can check one of the previous modules regarding the chain of responsibility. There we covered in much detail the troubleshooting techniques. But yeah, if you have to do some calculations, because right now we hard-coded some of the prices here, sometimes it's good practice, especially in such complex scenarios, where here, as I said, here we can have much more items and prices, like volume discount, coupon, which is a percentages coupon, or amount coupon that can be just applied for one of the products and not for 2 of them. So instead of hard-coding all of those prices, we can have a separate class responsible for calculating the expected results. It will be up to you. This is like architectural decision. But if you do that, maybe it's not suggested to put this logic directly in the page object, but instead you will have additional service class for that, like a calculator service. that you can later use in the range phase. As I said, we use those model classes that are grouping the input or output validation models. One model is just the so-called POC object, which contains just string or integer properties, a simple object, no actions there. So we are grouping, and here I changed, because this is my case, I changed here the quantity to 9, and then I changed the country to Croatia. The another change here when I use the page object lies in these three methods. I changed the VAT tax to 25, then I have the assertions for the VAT tax to this particular amount, and I change the total. Again, if I need to apply and write the second test case, the most dummy approach is to copy paste the whole method, like I did here. I updated the title for quantity 1. I continue to have Croatia. So I updated just the quantity here. The country stays the same. And then I updated these two prices. Now the VAT tax is lower than the first example with the 9. And of course the total is different. I did the same for Belgium, for quantity 9. We keep the quantity 9. Then we have Belgium here. And again, we copy pasted, and then we change here the VAT tax, pre-calculated and hard-coded everything. And I repeated that for a couple of more countries. You will notice when you clone the code that I actually made a mistake on purpose, because when you copy paste, it's a common mistake to mistake something and to forget to do it. Like here, on purpose again, I have Austria for quantity 9, and mistakenly I put here 1. I forgot to update it to 9. Probably this test will fail. Now, as you can guess, this is not the best and suggested approach, because we copy pasted a couple of times the same test. If you need to make even a single refactoring, applying and adding a new parameter to a particular method, or change the signature or something, especially with the parameters, this is a problem. Or if you need to add an additional step, you need to go to many tests and update it manually, which is not suggested. Copy paste is it's always you need to avoid it. Another technique, very simple, instead of directly copy pasting, is just to refactor and extract the method to a private method here. So I extracted the core logic of my test, if we accept that it always stays the same, and I added parameters only for the variable things here, like the quantity, the country, the VAT tax percentage, the expected VAT, and the expected checkout total. So now I changed them here, like the parameter. As I said, we have the parameters for the tax, expected, and the expected total. This is like a workable solution, and I use the private method here everywhere. This is much better than just copy pasting. However, if you need to understand what's happening inside the test, you need to go to its implementation by clicking Control and left click of the mouse. Then I will need to check again, and then I will have to return. Depending on the size of your file, this back and forth sometimes takes longer, and especially if you have more than one file, then you need to move this method to a base class or to another facade or similar class, which again, this back and forth is making the troubleshooting and understanding slower. Instead of doing that, there is now is the time to discuss the data-driven testing. What is the data-driven testing actually? This is a software testing pattern that involves separating the test logic, like here under this folder, data-driven. In a minute we are going to cover what this means, but basically I separated the logic from the data. So this involves separating the test logic from the test data. It allows the engineers to run series of the tests using the same test set of instructions or the code like I did here, but with different inputs and expected results. different inputs and different validations, right? This approach enables comprehensive testing of application functionalities under various conditions without writing multiple test cases for each possible set of inputs and copy pasting like we saw. And what are the benefits? The first most common one is, separation of data and the logic. The core principle of data-driven testing is to keep the data, the test data, the inputs and the expected outputs separate from the test script, from the logic. This separation makes the tests easier to maintain and extend later. We can also use external data sources, as we are going to see in a minute, like this type of CSVs. Test data can be stored in these external sources, databases, spreadsheets, XMLs, JSON files, or this type of CSVs. This makes it easier to modify the test data without altering the test code. We can use parameters, basically some tests like unit testing frameworks as unit accept our test to accept parameters. The same test logic is executed multiple times with different set of input data and expected outcomes of these external data sources. And adding new test scenarios can often be as simple as adding new raw data to this external source like this CSV, right? This data-driven testing allows for extensive test coverage with fewer test scripts and can significantly reduce the amount of code needed for testing and can help automate repetitive test scenarios. So, NUnit, this can be done, as I said, with NUnit, MSTest, XUnit. We're going to cover NUnit because it's the most used in the .NET world. Again, you have the same capabilities for Java, for JUnit and TestNG. There are other videos that I recorded for JUnit describing that. So, NUnit is a popular C# testing framework from version 2.5, offers support for these parameterized tests. It contains various NUnit attributes. We are going to cover most of them, or the most important ones for automated tests. So the first one, and my favorite, is the test case attribute that marks a method, like here, this method. We don't need those spaces. So we use it instead of the test attribute. So it annotates a test method. It also provides the inline data that needs to be used when that particular method is invoked. It can appear on one or more times on a test method. It doesn't make sense to just put one test case attribute. Probably you'll have more because you need, to apply the data-driven testing approach. And with each appearance carrying values for the test case. What else? This attribute helps in supports several additional named parameters like author, category, description, expected result, test name. You can also, when you use this approach with the data-driven, you can put like this attribute, special attribute, parallelizable, parallel scope all, and this will execute depending on the scope all of your tests in parallel. This is excellent when you combine it with the power of Lambda test and execute it into the cloud. But you need to be careful. If you use this approach, probably you will need to wrap the iWebDriver in this thread local container, which will basically isolate each instance of the WebDriver between the different processes. There are separate videos about that, especially when we covered XUnit. There is a dedicated video about that. So this is the first attribute, and it's very important to, as you can see here, we have the inline data. We have 5 parameters, and you need to make sure that you have the exact amount and the right type of the data. We have the quantity, we have the country, a string, but the default percentage is actually double. And NUnit is responsible for mapping the actual type of the parameters, right? It will going to parse it, to number, etc. But for example, if you provide here that this is double, and if you have the sign here, this will fail. And if the parameters doesn't match, then there will be a failure. So this is the first type of attribute. It's very easy. We are using the same body, but for all of this test data. Now, another very popular attribute is the test case source. This test case source attribute can be applied to any test method, just like the test case attribute. The property methods or fields specified by the test case attribute provide the arguments to the parameterized test. Unlike test case attribute that is used to provide simple compile time constants as parameters to the function, the test case source attribute can be used to provide more complicated parameter types. The another major advantage of this attribute is that the source method is reusable across different tests. The object data that it's part of the method using the test case source attribute can also be reused multiple tests. If we open this CSV data source, as you can see, this is a simple class. It provides one static method that needs to return IEnumberable. So the source specified by the attribute can be either return IEnumberable or a type that implements IEnumberable, like list. For simple tests, object array is fine, can be returned from the source. For more complicated tests, IEnumberable is used as the test case data. Another thing that it's very important to note, since we are returning IEnumberable, we need to use the yield return operator, which can speed up and is used for each statements. This means that if you break, we won't go over each of the cases. And here, the thing that I did here in this CSV data source is that we read and extract the data from the CSV source. There are other more simplistic approaches. There are some NuGet packages for doing that, but I used directly C# code like a stream reader and CSV reader. And here it's important to mention the name of the method part of the data source that needs to be used. And besides that, after that, we're just again have similarly the number of parameters that are required, and we're using the body. That's everything that we need to know. Another thing, part of the, by the way, you can check it in the resources below this awesome article and unit tutorial for data-driven tests with NUnit. I basically got the code from this value source. Value source attribute, as you can see, it can be provided inline for different parameters for the test method. It's very similar to the test case source, except that it's used as a method parameter. And using this value source attribute for creating parameterized tests in NUnit is especially useful for cross-browser testing, as in this example. As you can see, we defined these private static arrays of strings like browsers, browser versions, and operating systems, and author here make that code execute multiple times like combinations for cross-browser testing in the Lambda Test Cloud. I prefer another approach to solve this problem. You will find here another class called Product Purchase Tests Cloud. And I wanted to execute all of my tests in the Lambda Test Cloud because this is very important for front-end tests to be checked against multiple browsers, multiple browser versions, and operating systems. Lambda Test Cloud is excellent for that as an infrastructure provider. They provide all of those browser and browser versions. You can use the capabilities generator. You need to pick your language. For us, we need C#. we need NUnit, and we need to pick the browser version, right? But as I said, for example, if you're testing a banking software, then you need, as a compliance, to check it against multiple browsers and browser versions and to be sure that everything is working correctly. So here we need to provide the browser version, the operating system, and depending on the options, we will trigger the browser. And we can use the test fixture actually to provide and multiply all of the tests in this class and execute it against these different options. This is a very popular approach. So this test fixture NUnit attribute again annotates a class that contains tests, but we can provide multiple parameters to it since it provides a generic version of the attribute that was introduced in version NUnit 2.5. And so we can provide these arguments here. I initialize them in the constructor of this class, and later during the setup phase I have a switch. Of course, we can use adapter or similar factory method approach for moving this initialization logic. I wanted to keep it simple, but if you use additional classes, you will just provide the parameters to those methods. However, we extracted the the username and access key to the environmental variables. We get them here. We initialize the dynamically the options based on what we have in the attribute, and then again depending on the version and the operating system, we are multiplying those tests. And if I already reviewed the project, one key benefit of NUnit is that if we open now here in the test explorer, you will see that for every test, of course these are the copy-pasted tests, we don't care about them, but actually about the CSV, you will notice that NUnit, and based on the attribute that we have, multiplied our tests based on each row in the CSV and generated a unique test for us. The same happened for the test case attribute now. As you can see, we have a very good name with the quantity one, Cyprus, something, and all of the prices, which is excellent because this is not supported in all of the unit testing frameworks across multiple programming languages. But this is a big benefit because you can now directly debug this particular test, especially even if it's in a CSV. I prefer test case attribute when it's possible instead of using CSVs, because this makes readability of our test much clearer instead of going directly to this file and guess what's our case here. But it's a matter of choice. Yeah, this was everything that I wanted to show you in this particular video. Next, we are going to discuss the builder design pattern. So we covered, again, don't do the copy pasting when you have multiple test data. Maybe it's better to move it to private method, but instead use the power of your unit testing frameworks. Use the data-driven testing pattern to make your test much more maintainable and readable. I prefer test fixture approach and the test case attributes in NUnit. You can even combine them. Yeah. So thank you for watching. Check the Lambda test blog for many awesome articles about best practices in automated testing. If you have any questions, put them in the comments below. I'll be really happy to hear if you have wishes about other design patterns to be covered in this course. Also, follow us and get your free certifications about NUnit, JUnit, Selenium, and other important technologies. Thank you for watching, and see you in the next module.